Problem number 46, permutations. So you are given an array of distinct integers called nums, and the goal is to generate all possible permutations of this array. And a permutation is a way to arrange the elements in the array in different orders. For example, if we have this array, the different ways you can arrange these numbers are the following in this array. Like if you have 1, 2, 3, you can have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 2, 3, 1, etc. Okay. So we need to write a function that return all such possible orders or all such possible permutations of the input array. We can use a backtracking approach for that. To solve this problem, we use a backtracking, like an approach called backtracking. And backtracking is a technique that helps us explore all possible solutions by trying out one option. And if we hit a dead end, we backtrack and try another option. So the process goes into, let's say, 6 or 5 steps. The first one is just we need to start from the first position. So if we looked at this array here, the first thing we will do, we start from the first position. Okay. So we start with an empty path and build our permutations one element at a time. After that, we swap elements, like at each step you pick an element, swap it with another element, and explore how this swap creates a new permutation. For example, if we have 1, 2, 3, and we might start with 1 in the first position, and then try swapping the other element to create different orders for the rest of the numbers. So we can swap as much as we want. And after that, we should recurge. So after each swap, you go deeper into the recursion, which is a function calling itself to continue creating permutations with the remaining numbers. And after that, we add the permutations to the results. Like once you have filled all positions, you have created a valid permutation, so you save it. And in the end, we backtrack, like undo the swap, like after exploring one possible swap and the element back to their original position to try different positions. So let's see how we will do this in the code. So first we will have our result array, which is an array, which the result array, which is the variable or the array that we should return at the end. Okay. And after the result array, we will have our backtrack function. So I'll create a function called backtrack, and it will take like a start index, and I'll say if start index equals nums dot length, if that was the case. Okay, before I saying what I'm doing here, when we have a recursion function or recursive function, the first thing we need to think about is the base case, because as you know, a recursive function is a function that calls itself over and over. So we need to find a base case where we force the function to not call itself over and over, so it will not run forever. So the base case should be if we have reached the end of the array and the current permutation, okay, sorry, if we have reached the end of the array, and yeah, if we reach the end of the array, I guess there is no other numbers to swap with or to change with. So that means we have to end the execution, and we need to add the permutations to the results. So what we will do, we said result dot push everything in nums, and we should return nothing basically. So we did thought right now, and we did handle our base case. Let's look about the core functionality. So we create a for loop, okay? I would say for let I equals start index, okay? I less than nums dot length I plus plus, okay? I would say, okay, so we need to explore all possible swaps. So first we need to swap nums of I with nums of the starting index, because as we said before, we take a start index and we try to swap with to generate a new permutation. So how we will do this swap, I would say if nums, it's a pretty simple one, nums of I and nums of start index, that's okay, will equals, what is this? Sorry, this is my studying, German studying. Okay, so it should be, if we want to swap, this is how you do a swap in JavaScript. And so right now we did swap. And after we did the swap, we should call the function again. So like we choose recur for the next element, call the function again. So I will call the backtrack again here, and the start index b plus 1, okay? And I would say also I should backtrack by swapping the element back to the original position, because we should, as we said before, after exploring one possibility, we need to swap the element back to their original position to try out different combinations. So how we do that, we will do as it was before. No. So nums of I and nums of index, and nums of index equals nums of I. And I need to call the backtrack with the first element, with position, with the first one, with the position 0. And I guess we're done. Let's submit and see. It didn't work. Why? Because cannot set property. Okay, let's see where they did this wrong. Number 18. So nums of I and nums of start index should equals nums of start index and nums of I. I equals start index I less than nums length I plus plus nums of I, nums of start index, nums. What did I do wrong here? Let me see. So if start index equals nums of length, we resolve the push nums and we return. Here in the for loop, we have three things to do. Basically, first we swap, and we call the start index again. We call the backtrack function again, and cannot set property of undefined. Okay, this is weird. Nums of I and nums of start index I less than nums of length. Let me think about this one. Why it doesn't give anything? We call the backtrack. Let me clean everything to make sure that we are doing it right. So we swap here. So nums of I nums of start index and nums of start index with nums of I, and I would need to swap again. So nums of I and nums of start index equals nums of start index and nums. It should work in my opinion. But I don't know why it's not working. Let me see. Because in my submission, if we look at this one, if we view more, it's working. It looks it's the same. We call the backtrack function. We have the function here, and okay, the result array, the backtrack 0 result, and everything looks the same in my opinion. The start index equals nums length. We results the push nums. Let I equals start index. I is less than nums length. I plus plus. Okay, I don't know. I don't understand how this is possible. But let me just try to copy this and see if it is a problem or not. Okay, apparently there is something wrong. I did it, but I don't know what was it. I really don't. We could discover. Okay, so I'll take this as a homework for you guys. Tell me what I did wrong in my first solution. So yeah, let's see the submission again and how much later, please. How much it's okay. It's why? I thought it's so better than that. Oh, okay. We're beating 80%, like by submitting 2 times. Okay. So yeah, that's it for this for this video. And if you like my solution, make sure to subscribe and hit the notification bell so you'll never miss a video. And see you in the future.